So this is the simulation. Again, I wanted to show anatomical substrate for which we plan our surgical procedure. First of all, with MRs, you can see this lesion in the usual way, and then we try to build a sagittal image after we have gotten to see all this. And now you're trying to create the 3D image. Now you can see the extent of the tumor. You can put it together with standard imaging, or you can now start to build composite models of everything else in 3D. And one of the things we were interested in is what the relationship of the carotid artery was. Of course, you could tell it, but we wanted to know the whole cause because that was important for our surgical planning. And if we were to move this and start to get our vessels and turn it around, we can now start to understand the relationship between the tumor and the carotid artery. And the carotid artery actually, and you can see as you move away, you can start to see parts of the carotid artery. So the carotid artery is almost being embedded by to a certain extent by the tumor. So which meant that we need vascular control, otherwise there'll be the patient will have a vascular carotid injury and a stroke. So that was something important that we wanted to avoid. And of course we can put in the brain now and consider finally the whole 3D image. You can see a final image of the patient. You can see that there's a vast maxillary prominence here, and you can even generate a whole image of the face and all its bits in the cranial cavity. So we use our navigation system, so you're able to pinpoint all these lesions. This is an intraoperative image looking at the posterior aspect of the tumor. This is really with the low inferior towards looking at where the carotid artery is. Able to resect this tumor with a big hole here, a small amount of tumor in the cavernous sinus, which is treated with radiosurgery.